Welcome to the Nano Entrepreneurship Network podcast, where entrepreneurs who have transitioned ideas into the marketplace share some of the lessons they have learned and insights on the navigation of the technology development pathway. I'm Lisa Friedersdorf, Director of the National Nanotechnology Coordination Office. Today, I am joined by Steve Wilcenski, the CEO and co-founder of BNNano, an advanced materials company. Steve, thank you so much for joining us. To get us started, can you tell us a little bit about yourself and how you got started?
Yeah, first I'd like to say thank you, Lisa, for giving us the opportunity to talk to you today. So my background, I'm a scientist and engineer, and I'm starting to feel comfortable calling myself an entrepreneur. My technical background is founded in material science and engineering. I'm also a chemist. And for the last 20 years or so, I've had the really good fortune of being able to work with some really interesting technologies. And it's always been with the goal of commercializing a technology or a material into a new technology. So it's been pretty exciting. Started making specialized high efficiency solar cells for the exploration of space, moved into high powered LEDs. The blue and the green that you see everywhere today, they're really not that old. They've only been around for, 10, 15 years or so. And then I got into micro and nano machines. And I've been lucky to be a part of teams that have developed devices and technologies that have been implanted in human bodies. They've helped enable smartphone technologies, explored the surface of Mars, and I even have a couple things that have actually left the solar system. And all of this has always helped fuel a passion for material science and for the development of new materials that will enable and disrupt technologies that can hopefully make a difference in the quality of life. So it's not a unique story of how we started the business. My co-founder and my business partner, Jason Taylor, we started working together in the late 90s. And we were working together as process engineers for a company called Cree. And it really started there. We would talk at lunch and in coffee breaks about one day, what would we do? You know, the founders of Cree had an interesting story and they came up with this idea all on their own and they started a business. And we thought how awesome it would be if we could do that one day too. And for many years, we just talked about it, but we never lost sight of the idea and the dream. And it was really probably around 2015 when we started really focusing on trying to find something to do and find something to do together and how we would do it, what we would do. And right around 2016, we thought we had a good plan. We thought we had some good ideas. So we actually just quit our jobs and gave it a shot. We knew it was a risk. But we did have, phenomenal support from our close friends, from our families. We had financial support from friends and family and angel investors, and we took a chance. We actually started production January 1 of 2017, and we've been growing the business ever since.
Why was it that you and your partner felt that boron nitride nanomaterials made sense?
One of the really compelling things for us was that this was a single material that had so many interesting properties and could affect so many different applications and industries that it seemed almost too good to be true, right? I mean, it is a nanotube, so it has phenomenal mechanical properties. And just like a carbon nanotube in structure and mechanics, it can make things stronger and it can make things more durable. But it had a few compelling properties above that. One, it's thermally stable above 850 degrees C. So now you can start adding this type of material to things like metals and ceramics. It has a very rare combination of properties in that it's an excellent thermal conductor, but it is also an electrical insulator, which is pretty uncommon. Carbon nanotubes move heat very, very well, but they also conduct electricity. So there's a lot of things you can't do with them. Now we have this combination where we can find new ways to affect electronics, to cool electronics. It also, because it contains boron, it has the ability to absorb neutron radiation, which again comes up with some really interesting ideas. It moves heat so well that it can be a fire protected property. And then we've even done some experiments, and there's lots of literature to show that you can create new ways to filter and clean water with this material. So there were so many applications. But the really interesting thing for us was when we were doing this research, all of these papers would always seem to have this little statement that said, this is a phenomenal material. If anybody could ever figure out how to make it in quantity, make it in high quality, and make it cost effective, you might have something. But right now, there's no way to do that. And well, our background had been commercializing very complex materials, tertiary, quaternary material systems grown by thin film growth, making machines smaller than the head of a pin, smaller than the width of a human hair. And these are actually machines that move. So we've done some really crazy, complicated things. And we looked at it and naively thought a little bit that, hey, this just has boron and nitrogen. How hard can it be? And then the more we dug, we also found that there's almost no intellectual property carved out in this space. So there's a really good opportunity to create value. And we just learned more and more and more about it, and we got really excited. And then we just decided at one point in time, okay, this is the material we're going to do. But the only way this is going to work, we have to listen to what the papers were saying, that you have to be able to find a way to make this commercial quantities, and you have to make it cost effectively. And that's when we really took as much effort into researching the supply chains, the processes, the industrial engineering, and trying to find a way to make this into a business while at the same time we're trying to make this into a technology. Because if you can't commercialize it, nobody's really going to care. It'll just be an interesting article 10 years from now.
One of the things that we always talk about with respect to nanotechnology is the importance of interdisciplinarity and how it's brought different people together. How did you build a team in order to pursue that area?
So we started with who we know, which I think is a pretty common way to start. Jason and I, we've had the good fortune of working with some really good people. But we also have a tremendous support group of advisors behind the scenes. Our primary angel is actually the gentleman that invented the LED light bulb. So he's a physicist with an excellent physics background, but he has a really good ability to understand how to commercialize technologies. And that goes really down the line from advisors that are just advising because they want to, or some of the people that might have invested in us. We've been very blessed that we have a very large team behind the scenes. We don't have that many people internally, but we've been able to really learn from a broad group of very cross-functional disciplines. And we like to use the term process engineers more than what was your degree in, because it takes so many different types of people to understand that a small, subtle change that I'm doing today may have huge impacts down the line. They may make it harder for us to do things, or they may make it harder for our customers to do things. And if you do it right, just the opposite. So it's critical. And I think for us, the other really important thing has been to try to avoid people that all come from the same companies or even universities, so that they don't have an institutional bias of how they approach problems and solve things. For us, I think the most important aspect is someone who's a critical thinker that can come up with creative ways to do things is what's important. And for us, it's always been being able to have conversations between people that are chemists, that are scientists, that are engineers and physicists, because we're taught so differently and often approach problems differently. And you need to have all of those different perspectives, especially when you're in a small company and you really can't afford to make too many big mistakes.
Could you maybe share the best advice that you got as you were just getting things launched?
One of the best pieces of advice we got was very simple, but it applied to so many different things. And it was from one of our advisors who, he's also an investor, but we trust him dearly. And he's been around the block for a lot of different industries, a lot of things. And he would just always say simply, just focus on the close. And what he meant by that was that, yeah, the home run is great, but as a small company, you need small incremental successes. You need to piece together small wins across everything that you do, be it growing your revenues incrementally or developing your technology or adding to your team. It was, don't lose sight of the big things that you can do, but if you don't focus on the close, you're going to make it harder for yourself. And that was always something that I think we tried to listen to. We didn't always listen to it. And often when we didn't, we had trouble, but it was just something that's just very, very simple. And it resonates through every part of growing a business.
As you look back, developing this nano material, what makes nano different? Where have you been able to find the resources to characterize your materials or address some of these other more nano-specific issues?
One of the challenges is the specialized analytical equipment that you need to analyze what you're doing, confirm what you're making, do quality control, and to really provide the data that a lot of your customers are asking for. And in most cases, this is very expensive, hard to maintain, sometimes hard to find. And what we've done is we've partnered with the Joint School of Nanoscience and Nanoengineering in Greensboro, North Carolina, which is part of the North Carolina A&T and the UNC Greensboro joint effort. I believe it's also part of CNIC. But what that means is for an annual fee, we get to join this organization. And once trained, we get 24 hours a day, 7 days a week access to a phenomenal tool set, multi-million dollars worth of equipment. Everything from SEMs and TEMs to crystallographic equipment to TGAs, some of the simple things, some of the complex things. So what it means is we don't have to spend money on that equipment. And the other thing that it means is we don't have to have someone else measuring what we're making and telling us what it is. A lot of times what we're working on has never been done before. The data has never been taken. So you learn a lot by doing the analysis, right? We can very rapidly test, get new results, do new experiments, and go back and test again for very, very low cost. And I believe as we look back, probably the best decision we ever made was to locate close to this facility. And without it, there's no way we would be where we are today. We would have probably spent 10 times, 100 times what we've spent just on analysis.
So looking back over the past few years, can you share a strategy or a decision that you made that maybe in hindsight you would do differently?
Definitely. And this went completely against the focus on the close advice that we were given. We were located in a small town in North Carolina called Burlington, which is a formerly very proud textile town. So there are a lot of idle textile mills, and we happen to be in one. And because of where we are, we said, hey, let's try to make a difference here. What if we could create a way to make polyester a much more high value product? And we found a way to compound our material into polyester, and we improved it. And we thought, well, we can just make a polyester yarn that everybody's going to want to buy. But we didn't take the time to realize the big picture and understand that there is such a variety of specifications and demands for material like polyester that you can't just simply sell one thing. So we did lose a fair amount of time and some dollars developing a product that in the end we should have done more homework on. And we should have focused on close. We should have maybe stopped a little bit short of where we went, but we got excited. We kind of lost sight of some of the things we were doing. And ultimately, I think that'll pay off, but it certainly wasn't the right thing to do at that time. And that has forced us to rethink when we get into some new ideas and some new products and developments, to where we need to spend the time and do a little bit more of the traditional marketing and some of the traditional research that again goes back to a sort of traditional business problems outside of nano. And the more that we have treated nanotechnology just like everything else, the better off we've been.
When you were looking at making polyester threads that incorporated your material, were the applications looking at things like smart textiles or energy harvesting? Can you expand a little bit on the applications you were considering?
We were actually looking at it more from a defense standpoint. We were trying to create a polyester-based material that would have properties similar to aramids. Say, if you could make a low-cost Kevlar, for lack of a better way to describe it, there'd be some potential there as well. And then also the advantage is if we could add our material and create a bit more of a fire protection aspect. Some of the awnings and acrylic materials and some of the other things that are sometimes above your head don't necessarily need not to burn, but if they burn differently or slower, that could be an advantage. So we were thinking more of a toughness and fire protection.
When you look back over 2020, can you share some of your challenges and triumphs?
Yeah, it was certainly a challenge at the beginning of the year. We thought this was going to be the big growth year for us. And then with all of the challenges with COVID, we immediately went to how do we keep everything together? How do we stay in business? And we were able to take advantage of that in a few different ways. One way was we got invited to participate in Pepperdine University's Most Fundable contest. And this is open to any company that makes less than $10 million a year in revenue. And I believe there were 4,500 participants this year. And we were actually one of only 3 companies to be awarded the platinum designation in the Most Fundable competition. So we were very excited and humbled by that. And I think the really interesting thing is that it was technology agnostic. they didn't care that we were making nanomaterials or boron nitride nanotubes. It was a testament of the business plan and the business that we had. So it was a outside organization, a prestigious university, given essentially a stamp of approval. And what that's meant for us is we've been able to be introduced to some phenomenal people and organizations, and we've been able to have some very interesting conversations to help really plan our growth going into 2021 and have additional opportunities for funding, collaborations, partnerships, and even customers. So it has been essentially a nonstop activity of just communicating with new people since that award came out. We also were awarded an innovation award from Global Smart Leaders magazine. We got a innovation award from Tech Connect, which is a technology sort of incubator organization. And we've been blessed to have these things happen to us. But the other thing that sort of the slowdown gave us was the opportunity to have conversations with companies and people that didn't have time for us previously. So it was a chance to reset, reevaluate what we're doing, and focus on those relationships, focus on growing a traditional business and really establishing that. So I think it was certainly a challenging year in many, many ways, but hopefully when we look back, it will also be an inflection point to where we can see we really took advantage of what was in front of us, and it really gave us that strong foothold and foundation to move forward.
So Steve, I really have enjoyed our conversation today, and I appreciate your time. I want to maybe close by asking, what advice would you give to an entrepreneur who's just starting out?
Yeah, there's a few things. And I think the first thing and the most important thing is relationships matter. It doesn't matter how technical your business is or how rare your product is or how great you think it is. People are going to be making it. You're going to be communicating to people to buy it, and you're going to be working with people to make sure it does what it's intended to do. So the relationships are critical. What we found is it's oftentimes not the person you're speaking to directly, but it might be who they introduce you to or who they know that might ultimately be the person you're going to work with. But you can't take that for granted. And you also have to take that into account with your team. Everyone on your team is critical. Ultimately, other people are going to figure out how to make boron nitride nanotubes. Other people may figure out a way to do it better. But if your team is excellent, you have a good chance of having an advantage. So you need to always treat everyone together with the respect that they need. You need to have a diversified group. You need to have different backgrounds. And you really need to focus on that relationship aspect of things. The other really critical thing for us was hyper-focus on what you need, not what you want. And that goes everywhere for us. And one of the examples we have is, we're in that old textile mill, in that old textile town, which is a 45-minute drive from a city. Well, what that meant for us is huge cost savings, right? We don't need to have a fancy building. We might want it, but what we need is a building where we can do our process. And we took that philosophy and really spread that over everything that we did and focus on what you need, wait for the wants later. And that's been really important. And then the last thing I think is fairly obvious, but you got to be adaptive. I think one of the things we've all learned this year is we didn't end up where we expected to be in January. And you need to not lose sight of where you're trying to go, but you have to be flexible enough to maybe take a different path or to try something new or to be creative in how we work together. And as long as you can sort of stay true to what you're trying to do and you have that flexibility, people have a really good way of dealing with challenges. And I think letting your people deal with challenges is also part of that. So it's ultimately, even with nanotech and with what we're doing, it's all about the people that we work with.
I really enjoyed our conversation today, and I really thank you for sharing your experience. And for those of you listening, if you are interested in getting involved in the nanotech